Welcome to solverfy.
For this question, we are looking at what is the dose a person will receive from drinking milk. Right, so we want to find what is the total dose received by the person in a year due to the milk. Start off with a single day first. So for a single day, the person we are given drinks 0.5 liters of milk. And from this 0.5 liters, we know that the activity is 2000 picocuries, which is 2000 times 10 to the power minus 12 curies per liter. And from this curies, we need to convert into decays per second. So this number of decays per second per curie. But for each day, we need to find out how many seconds there are, right? Multiply that by the number of seconds per day, which is 24 times 3600. But we are given that only the milk only stays in the body for 12 hours, right? So for each day, it should be only 12 hours. So considering only 12 hours a day, and this will give us a total of 1598 times 10 to the power 6 decays per day in the person's body, right, due to the milk. Next, we can find what is the energy that is being absorbed by the person per year, right? From here, we move on to a year. So the energy absorbed in a year, we take the number of decays in the day, multiply that by the number of days in a year, that is about 365. 365 days, and then we multiply that by the energy that's released per decay, that is 1.5 MeV. But we are given that only 10%, right? 10% of this 1.5 MeV is absorbed by the body. So we gotta multiply that by 10%. Next, we want to convert MeV into joules, right? Because dose is in terms of joules per kg. So we multiply this MeV by 1.6 times 10 to the power minus 13 joules per MeV to get our answer in terms of joules. You should get 1.4 times 10 to the power minus 5 joules. So this is the energy that's absorbed in a year. Now we want to find out what is the dose for an adult versus a baby in terms of REM. So REM, basically we have to take the dose in terms of rats, multiply that by the RBE, relative biological effectiveness, which is dependent on the type of radiation that we're looking at. But for our potassium, right, the radiation type is basically gamma and beta, and so the RBE is 1, right, for gamma and beta. So basically REM is equivalent to rats, right? It's the same. There's no conversion factor that's needed. So what we need to do now is to find the dose. We have already the total energy that will be absorbed by the body, just take the energy, which is 1.4 times 10 to the power minus 5 joules, divide that by the mass, which is 60 kilograms. This will be in terms of grays, but we have to convert from grays to reds, right, or millireds. So to convert from grays to millireds, we have to multiply by 100, 10 to the power of 5 millireds per gray, which is in terms of joules per kg. Alright, and since we are already given that rad is equals to REM for this case, we don't have to do any conversion factor, right? The 1 millirad should be the same as 1 REM, 1 milli REM. Right, and we should get a value of 2.33 times 10 to the power of minus 2 milli REM per year, compared to the limit of allowed dose, that is 100 milli REM. This is much smaller, right? So it's not very significant for an adult. Now we do the same process, but now for a baby, a 6 kilogram baby. The same amount of energy is being absorbed, but the mass of the baby is only 6 kilograms. And so the answer that we get is actually quite different. It is about 0.2 milli REM per year, which is much closer to the allowed dose as compared to an adult, right? So for the adult one, we take 2.33 times 10 to the power minus 2 divided by the allowed dose, which is 100. We get about 2 times 10 to the power minus 4. So this is about 2 times 10 to the power minus 4 times of the allowed dose. Whereas for the baby, it is 0.2 divided by 100, which is about 2 times 10 to the power minus 3 of the allowed dose.